All right. So first step in predicting any reaction is deciding what kind of reaction is going on. Okay, in question number 1, I've got an ionic compound in beryllium sulfide reacting with an element, a non-metal bromine. Okay, so what kind of reaction is that going to be? Single replacement. All right, so in a single replacement reaction, we have to swap the thing that's alone with what's like it in the ionic compound. Since this is a non-metal, we're going to swap it with sulfur. Okay, so that means beryllium ends up with bromine, and sulfur ends up by itself. Now, we got to look for specials and swap and drop our ionic compound. Okay, bromine's a -1, beryllium's a +2, so we're going to have BeBr2. Give them 1 mark for that. Okay, if they had BeBr2. It didn't have to be first. They could have listed it second if they wanted. Okay. And is sulfur special? S8, 1 mark for that. All right, then we got to balance the whole thing. That'll be their 3rd mark. Start with the largest number. There's 8 sulfurs, so I'm going to put an 8 here. I'm going to put an 8 there to give me my 8 berylliums, and that's going to give me 16 bromines, so I need an 8 there. Okay, so we're looking at 888 blank or 8881, whichever they wrote. That's their 3rd mark. Questions on number 1? Okay. Question number 2, I've got an element reacting with an element. What is that going to be for a reaction? Okay, it's a synthesis reaction. You recall the other day I told you, I will try and trick you. I tried to trick you. When you put these two together, it makes an ionic compound. The metal must be listed first in an ionic compound. Okay? Guys, I will never say I'm going to trick you and then not do it. Okay? So every time I say I'm going to trick you, know that I'm telling you I'm going to trick you. Okay? Yeah. All right. So this is -3. Okay? This is going to be +1. So we got to drop and swap. So we got K3N. So they got to have that. That's your only product, and it's worth 2 marks. And it has to be written K3N. All right? They didn't have it. Okay? They don't get those 2 marks. Now we got to balance. Now, I usually go with the biggest number, but I know if I put a 3 over here, I'm just going to have to start over again because nitrogen won't work. Okay, so I'm going to start with nitrogen and put a 2 here, which gives me my 2 nitrogens and 6 potassiums. 1, 6, 2 for the balancing. 1 mark for the balancing. Questions on number 2? It's out of 3. Yeah, they're all going to be out of 3. All right, for number 3, I've got copper 2 sulfate, an ionic compound, reacting with sodium hydroxide, an ionic compound. What kind of reaction is that? Double replacement. All right, in a double replacement reaction, we swap the metals. So sodium ends up with sulfate, and copper ends up with hydroxide. If they had the copper and hydroxide first, and the sodium sulfate, that's fine. It doesn't matter which order. Okay, they go in as long as the metal is first and the non-metal is second in the compounds. All right. Each of these are ionic compounds, so I got to drop and swap each of them. This is a -2 and this is a +1. Holy smoke, while I'm talking, can you listen? Okay. Na2SO4. All right, for this one here, copper is a multivalent metal. It could have more than one possible charge, 1 or 2. This side tells me it had to be the +2, so I use +2 on this side, which will give me CuOH2. All right, 1 mark for each of those ionic compounds. Now we got to balance the whole thing. Present in the largest number, sodium. Putting a 2 here balances the sodium. It also balances the hydroxides. Copper and sulfate are present as 1s in every position. Now it's balanced. Okay, so 1 mark for the balancing. Questions on number 3? Okay. Number 4, I've got a carbon and hydrogen containing compound, also known as a hydrocarbon, that is reacting with oxygen. What kind of reaction is that? Combustion. Products of combustion are always carbon dioxide for 1 mark and water for 1 mark. Special balancing rules. Balance alphabetically in the rule of 2. Do I need them both? Yes. Okay, 4 is an even number, so I apply the rule of 2. That gives me 8 carbons. Okay, 2 times 10 is 20. 10 times 2 is 20. So 8 times 2 is 16. Plus 10 more oxygens is 26. 13 times 2 is 26. I think that is about the 15th or 16th time we have done that exact reaction in class. Each one is out of 3. So you get 1, and then you get 1 for the balancing. Okay, 1 for each product, and 1 for the balancing. All right, in question number 5, we only have a single reactant, which means it has to be what kind of reaction? Decomposition. So it's got to split up into manganese and chlorine. All right, I got to check for special elements. Manganese is a metal, and there aren't any special metals other than hydrogen. Okay, and we got chlorine, which always comes as a pair, so we put a 2 there. So 1 mark for manganese, 1 mark for chlorine, and then we got a balance. There's 4 chlorines over here, a 2 there. We'll take care of that. 1 mark for the balancing. Questions on number 5? Okay, give them a mark out of 15 at the top so that I can see it. Okay, give it back to them. Double check that your name is on it, and then hand it in on this desk right here. So, that was your first prediction quiz, right? We haven't been doing predicting that long, right? So it's okay if it wasn't the easiest thing for you. Remember, I mean, we're going to have lots of quizzes. You'll probably have another quiz on prediction on Tuesday. You will. Okay, so you get another chance at it. It's not the purpose of the quizzes, guys, is to review our skills. It's not really a way for me to assess you. These are not heavily weighted. Okay, they're not heavily weighted. If you do poorly on a couple here or there, it's not that big a deal. Okay, you got to do good on the exam. That's important. Okay, these give you an idea whether you're good at this stuff yet or whether you need a little more practice at it. Okay, and I expect that at this point we probably need a little more practice on it. Okay, this is one of the tougher things in this unit. Okay, so how many people have done the prediction sheet I gave you yesterday? Okay, it's kind of what I thought. All right, so let's continue working on that for now. If there are ones that are giving us trouble, we can go through them together. And then a little later on in class, I'm going to go over these 11, or we'll do them together and kind of go over them one at a time, just so we get some more kind of solved examples of how these work. Yes, it is already in the drawer over in that little drawer unit there. The one chemistry, or Science 10 chemistry stuff. Okay, and it always has to do with something reacting with water, and you can see there's a whole bunch of those. Okay, for each reaction where something is reacting with water, there's actually 2 possible answers because 2 reactions kind of take place, right? For this one, for number 1, let's say with potassium being added to water, okay, I can write water like this, and it's still a single replacement reaction. It's an element reacting with a compound. Yes, water's not really ionic, but water's the exception to every rule, so water can also be ionic. Okay? Now, in this compound, the nonmetal is oxygen. This is a metal. So potassium is going to end up with oxygen, and hydrogen's going to end up by itself. Okay? Hydrogen is special, and this needs to be dropped and swapped. Okay? So we'll have K2O, and then we can do our balancing. Okay? If I put a 2 over here, sorry, I don't mean to put a 2 over there. I need to put a 2 in front of this one. Okay? Everything is balanced, and it works. There's a second option. If you write water instead of as H2O, but write it as HOH, you get a slightly different looking reaction. Okay? Now, my nonmetal is hydroxide. So on this side, potassium ends up with hydroxide, and hydrogen ends up by itself. Okay? It's still special. I still have to have a 2 there. So now I got to go back here and go, all right, now I've got 2 hydrogens. Now I've got 2 hydroxides and 2 potassiums. All right? Either one of those is acceptable, and it's the same basically every time water is involved. If you write water as H2O, only the O goes. Okay? If you write it as HOH, the OH goes. Everybody follow me on that? Then it works the same basically every time water is involved. Okay. So for our first one here, we got sodium chloride reacting with calcium oxide. 2 ionic compounds means it's what kind of reaction? Double replacement. Okay. So in a double replacement reaction, we're going to swap the metals. We're going to have Ca with Cl, and we're going to have sodium with oxygen. All right, so we've paired them up. Now, because they're ionic compounds, we've got to swap and drop. So this is a -1. This is a +2, so we're going to have CaCl2. Okay, and then this is a -2, and this is a +1, so we're going to have Na2O. All right, so now we've got our products swapped and dropped. Now we've got to balance the whole reaction. Sodium and chlorine are both 2's on this side, so if I go over here and put a 2 in front of that, it makes them both 2's on that side, and now the whole equation is balanced. Okay. All right, number 2, okay, is a little bit tricky because we got some big numbers in here, and it's a single replacement reaction. So first thing, it also involves a multivalent metal in iron. So this is a nonmetal, and bromine's a nonmetal, so they're going to switch places. So Fe is going to end up with sulfur, and bromine's going to end up by itself. Okay, bromine is special, so I got to put a 2 on it. And now I've got to drop and swap this compound here. This is a -2, and we found out on this side that iron's a +3, right? If we look at that. So that means I'm going to have Fe2S3. Now, when we get to balancing this, these are going to be some big numbers, right? Because we got an 8 in there, and then we got an 8 in there with something that's got a +3 charge, so it's really going to give us big numbers. So I've got 8 on this side, and I've got 3 on this side, okay? So what's the lowest common multiple of 8 and 3? 24. Okay, well, that's what we got to do. So I'm going to put an 8 in front of this and a 3 in front of that. Now my sulfurs are balanced, but it gives me 16 irons. So I got to go over here and put a 16 in front of that. That's what I got to do, so that's what I did. All right, 16 times 3 for my bromines is 48 bromines. So I got to go over here, and I got to put a 24 in front of bromine. All right, I've got 48 bromines and 48 bromines. Okay, I've got 24 sulfurs and 24 sulfurs. I got 16 irons and 16 irons, and I can't reduce anything down because of that 3. Those are my final balancing numbers. Okay, they're big. It happens sometimes. Don't let it throw you. Okay, just if they're big, check that you can reduce them or not. Right? In this case, I can't. Okay, I can't divide all those numbers by 3. So. Yes, if the 3 had been a 2, I would have been able to reduce everything by dividing all of it by 2. All right, for number 3, what kind of reaction are we looking at there? Combustion reaction. Products of a combustion reaction are always carbon dioxide and water. Okay, we just got to make it balanced now. I got an even number of carbons, so I do have to apply the rule of 2. 2 times 8 is 16, so I got a 16 there. 2 times 18, okay, it's 36, so I got to have 18 over here. So I've got 16 times 2 oxygens, that's 32, plus 18 more is 50. So I need 25 times 2 is 50 for that one. All right, again, got some big numbers. That happens sometimes. All right, what kind of reaction is number 4? It's a synthesis reaction. I got 2 elements going together. All right, beryllium and fluorine. So when I put them together, that makes a metal, non-metal ionic compound. This is a -1, beryllium's a +2, so we're going to have BeF2. That works out nicely because now the whole equation is also balanced. Okay. Is this ringing a bell, making sense? All right. Number 5, well, I only have 1 reactant, so it's got to be what kind of reaction? Decomposition. So chromium ends up by itself, nitrogen ends up by itself. Chromium's a metal, there aren't any special ones except hydrogen, okay? And nitrogen's special with a 2, so I got to go back here and put a 2 in front of chromium nitride and a 2 in front of chromium there, and now the whole thing is balanced. Okay, keep going on that one.